Today's lesson is over right triangle trigonometry, and this kind of picks up probably things that you've already done in previous classes, physics being one, possibly honors integrated two, and it's very easy stuff, to be honest with you. It's based on right triangles. So the first thing we're going to look at is make sure we remember that the legs of a right triangle are the sides that make up the right angle, and the hypotenuse is opposite the right angle. I think that's kind of common sense. We can also look at this in regards to our unit circle, which we have done many times, and our x and y basically are our a and b when we look at our a squared plus b squared equals c squared, and our c is typically r. And unbeknownst to you, we've been doing right triangle trig this entire time. Using the initial side and the terminal side, we created a right triangle. But instead of x, y, and r, we're going to call it a, b, and c. So the 6 ratios of a right triangle, I think we know all of them. We just learned them in a different way the first time. The second time you learned them was in this class with the unit circle, and now we're back to just looking at right triangles instead of a unit circle. And the sign is going to be opposite over hypotenuse. So the sine of this angle is opposite over hypotenuse, O and H, B over C. The cosine is going to be adjacent over hypotenuse. The tangent is opposite over adjacent. I'll just go ahead and write these. And that's the hypotenuse. So B over A. And then the other 3 we don't really use, to be honest with you. So when you're looking at SOHCAHTOA, as we call it, SOHCAHTOA, this is just an acronym for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. When we use SOHCAHTOA, we are always in degree mode. So we need to make sure that our calculators are in degree mode. And here are the trig functions summarized in regards to that triangle. Opposite over hypotenuse, opposite over adjacent, adjacent over hypotenuse, and so on. SOHCAHTOA. And there's your acronym. Okay, so if we're going to find the value of each of the 6 trigonometric functions of angle theta here, 12 is opposite, 13 is the hypotenuse, and the adjacent then would be 5 using the Pythagorean theorem, or the fact that it's a triple. So if we're going to find all of them, we're going to first look at sine theta, which is opposite over hypotenuse. SOHCAHTOA. So opposite over hypotenuse is 12 over 13. Well, we know then that cosecant would be 13 over 12. Well, this looks familiar. The cosine is adjacent over hypotenuse, so the secant is hypotenuse over adjacent. It's a 3, by the way. And then the tangent of theta is opposite over adjacent, 12 over 5. So the cotangent of theta is 5 over 12. And all of the other things we learned in regarding to solving these in our trigonometric functions that we just took a test over, this is how we're going to solve these as well. Okay, and there's all the answers. All right, now we know the reciprocal identities. We know all those. We know that sine squared plus cosine squared equals 1. That's just a proof. Now, to solve a right triangle then means we're going to find all the missing sides and all the missing angles. So if we use this first figure, if A is 4 and alpha is 35 degrees, find B, C, and beta. Well, beta is easy to find because there's 180 degrees in a triangle. So we're going to subtract 90. We have 90. So 90 minus 35 is 55. So beta is 55 degrees. Now, it doesn't matter which angle you choose to use SOHCAHTOA to find whatever we're missing. I can use either the 55 or the 35. It does not matter. So in this case, if we let's find B first. So here's B, and I'm going to use 35 degrees. So that's opposite, adjacent, and hypotenuse. So if I'm going to find the adjacent side, I'm going to use opposite over adjacent, which is tangent. Again, you can pick it any way you want. So that would be 4 over B, opposite over adjacent. Well, this is where the algebra would come in. I would have to multiply by B and then divide by the tangent of 35 degrees. So 4 divided by the tangent of 35 is approximately 5.71. Okay, now let's say I want to find C. Well, I could find C using the Pythagorean theorem if I wanted. I'm going to use sine of 35, which is opposite over hypotenuse. And then I'm going to go through the algebra, divide by sine of 35. So it's 4 divided by sine 35. So C is approximately 6.97. Well, we just solved the equation. Beta is 55 degrees. That's how we use SOHCAHTOA. So here, more of what we use SOHCAHTOA for is applications. A 25-foot ladder leans against a wall, forming an angle of 70 degrees with the ground. How high up the wall is the top of the ladder? Well, here's your angle, so H would be opposite the angle. Well, 25 already has a name. It's always the hypotenuse because it's opposite the 90. So if we're going to use opposite and adjacent, or hypotenuse, excuse me, well, that's sine because it's SOHCAHTOA. So it's the sine of 70 equals H over 25. And now we just solve the equation. Now, since the variable is in the numerator, it's a simple 25 sine 70. We don't have to do any dividing, which is super nice. So approximately 23.5 feet is how high up the ladder would go. Yola just planted a hybrid elm. The nursery claims the tree grows 12 feet per year. Yola wants to verify the claim. She walks 100 feet from the base of the tree and using a transit that measures angles, that's 2 feet off the ground, it determines the angle of elevation is 5.7 degrees. 1 year later, she does the same exact thing and finds it's 11.9 degrees. Is the nursery's claim that it grows 12 feet per year true? Well, here's the picture. Okay, so we have some varying degrees of height, but we cannot find G, and here's why. Just by using triangles. Because this triangle right here is not a right triangle. So we can't just say, hey, here's what G is. We have to find H, then the whole thing, and then subtract them to find G. So that's not so bad. So we know the tree is not growing perpendicular to the ground. So if this is our angle, let's first look at 5.7. H would be opposite, 100 would be adjacent. Well, opposite and adjacent, SOHCAHTOA, is tangent. So the tangent of 5.7 would equal H over 100. Okay, multiply by 100. So 100 tangent 5.7 is about 10. So H is about 10 feet. Okay, so G then needs to be about 22, correct? So your initial height actually would be 12, wouldn't it? because we'd have to add these 2 feet in here, right here, but we'll take care of that later. Let's call this x. Well, then the tangent of 11.9 degrees would be x over 100 multiplied by 100. 100 tangent 11.9 gives us 21.07 feet. Well, if I find g then, 21.07 minus 10 is 11.07 feet. So does this hybrid elm grow 12 feet per year? No. It only grows 11. Well, 11, 12, that's still pretty accurate, pretty close. Now you may ask, why didn't we do anything with this 2 feet? Well, because we're measuring it from the same place. I could make 12 and make this 23.07, but we're still going to get 11.07. So it's kind of a waste of time to do it that way. Okay, so you have a SOHCAHTOA worksheet, and I would like you to get busy on that.